So, hi everyone, I'm Joey, this is Chris. This presentation was supposed to be done by Jacob, but unfortunately our good friend was ill and couldn't make it, so we're kind of taking over his presentation and hope to portray the information that he's trying to get across. We're both by Collabora. So a quick little introduction. I'm Joey. I've been at Collabora for almost a year now. Originally, I'm from the OpenHMD community, doing open source for like the last 10 years probably, and picked up VR and AR basically as a hobby, and eventually kind of escalated to where I currently own 12 of these little devices, and most of them weren't even doing anything on Linux before I got my hands on them. So a lot of reverse engineering work. For the last year, I've been working on Monado for Collabora and some contract stuff. I recently started on the XR desktop, which my colleague can probably talk more about. Talking about my colleague.
So my name is Christoph Haag. You may have heard my lightning talk yesterday about XR desktop. I joined Collabora about 1.5 years ago, and I have been working on Monado at first and XR desktop lately.
So we're going to do like a quick introduction to what AR and VR and XR actually means, and the issues we have with it and what we're trying to do as a solution. So what is AR and VR is a question that I get quite often. First of all, I want to start with the name HMD. It's a term that gets tossed around quite a bit, even before AR and VR were things. It's basically the concept of taking a screen and some sensor and duct taping it to your face. And all the devices these days that we're using are HMDs. So whenever it's an AR or a VR headset or whatever, most of the standards are some form of screen, some form of tracking solution, which can either be an IMU with an accelerometer and gyroscope. It can be photodiodes and lasers that like extrapolate position. It can be camera tracking, either inside out, so from the perspective of the HMD, or the other way around, where the room is trying to get the information from the HMD. So augmented reality is something that's been thrown around quite a bit these days. It's quite a hype to a certain degree, where everyone is trying to get on the bandwagon. Of course, this is what we try to achieve, so to augment the real world with digital interfaces. So the idea that eventually we will have some sort of transparent screen in front of our face and be able to put information on there, or maybe project 3D information into the real world. This is unfortunately what people think AR is at the moment. The whole concept of just like, hey, we have a camera and let's put a 3D model here and now it's AR, right? And it's unfortunately a little bit more difficult to get things into a usable solution. What is virtual reality? Well, it's basically the concept of AR, but without the whole interfering with the real world. Is we take two screens, we do some camera work where we are rendering two cameras at the same position of the eyes. There's some crossover in there. We do some undistortion, and then you get a 3D world, basically, with whatever you put in there. Like, it can be something real simple. It can be really expand. It's quite interesting what you can do with it. So this is kind of like the current example of your applications with quite rudimentary interfaces. So most of the VR applications try to have positional track controllers and do something with some form of presence. The word presence or immersion is thrown around quite a bit in VR. The whole concept of like being aware of yourself within a virtual environment. We come a long way. This was like our experiences a couple of years ago, and currently we're trying to put people into virtual worlds, which is pretty insane. So what is XR? XR is basically the name that encompass everything that has to do with AR and VR. So I guess it's like cross reality, or like, I don't really know where the name originated, but because people started making their own terminology, also like mixed reality and that kind of stuff. This is kind of the all-encompassing term.
Or extended reality.
Yeah, extended reality is also one of the names that get thrown around. So we have been developing Monado, and Monado is a OpenXR runtime, the first XR runtime on Linux that allows you to use VR and AR devices. So we're going to dive a little bit into what OpenXR is. It's a Khronos standard that they made when they found out that there's like this big issue with companies trying to all make their own SDKs, all make their own interfaces. It's really difficult as game developers to target a certain device because everyone was doing their own thing. OpenXR is kind of the solution for that, to make one specification that people can implement in their own driver. So games and applications can just target one specification in order to get their stuff running. Chris will tell a little bit more about the problem and the solution here.
Yeah, so as Joey said, on the left side, we have the situation before OpenXR. We have every engine that exists on the top. That is either an engine or a single application that directly implements VR support. And before OpenXR, every engine had to add support for every runtime that exists. And part of the issue is that most runtimes only support certain devices. So if you have an Oculus Rift, you need the Oculus Rift runtime, and the application you want to run also has to support the Oculus Rift runtime. And when we have OpenXR now, the applications and engines only have to support one interface, and all the runtimes will implement this one interface. So the same application only needs one code path. The device layer that is currently on the bottom here will be implemented in later specifications. It is not in 1.0. That's slightly misleading, but yeah, it will be there in the future. So that's what I was mentioning. And a program so how do we do XR? Our stack is basically 3 layers. We have on top our program that wants to render a VR world or some application that shows augmented reality stuff or virtual reality stuff. It has to use a software platform somehow that supports rendering stuff and supports getting input data. And on the bottom of the stack, we have the actually hardware with sensors that provide this data and a means of rendering stuff. So I will go on with a short overview of the API that is by no means complete. It's just a short overview about the stuff you can do with the API. If you are interested in more, the full specification is hosted by Khronos, like the Vulkan specification. You will find it if you DuckDuckGo it. So how do you actually use VR with OpenXR? So the API is roughly related to Vulkan. So as an application, you first create an XR instance that is somewhat similar to a Vulkan instance, in that it is basically a handle to a driver, which is basically our OpenXR runtime. OpenXR supports form factors. Currently, in the specification, there is a handheld display, which is basically a smartphone like this. And if you render augmented reality stuff like this, you can wave it around, and it will render stuff from the direction you are pointing it in. And the other big one is, of course, head-mounted display. Yeah, a head-mounted display that you attach to your head. There are few configurations you can use. The smartphone-based or handheld-based thingy has one monitor, which is basically one view, and an HMD like this has two monitors, basically two views, one for each eye. So once you have your hardware setup done like this and chosen which form factor you want, you create a session, which is basically a rendering context. There is support for D3D 10, 11, 12, OpenGL, OpenGLES, Vulkan, and there's even set up without any display that may be useful for other applications. Right now, there are unfortunately not simultaneous sessions, so we can only run one XR application at a time. But in the future, this will probably change. Mostly because we need this for XR desktop, where we want to display windows on top of VR applications. A very short mention, XR creates SoftChain, which is a command to create textures that you will use to send your rendered images to a runtime. I will not go deep into rendering, so this has to do for now. Rendering with OpenXR works in a cycle where you call XR wait frame, XR begin frame, and XR end frame. XR wait frame basically makes you wait until the previous frame has finished rendering. Then you get a predicted time when the next frame will be rendered. And all the position data that you can get from OpenXR will be predicted for the time the next frame will be displayed. So for rendering, there are a bunch of methods supported for rendering. The composition layer, the protection layer, is basically your normal VR application where you render two views, one for each eye. There is also a quad layer, which is basically a rectangle that you can place in 3D space. And there are a bunch of optional rendering methods. Augmented reality is actually not very well supported by OpenXR right now. This will be expanded in future versions, but there is some preparative things. This is the blend mode. So your normal VR application that doesn't have any see-through things has the opaque blend mode, but if you have a transparent display, you can use the additive or alpha blend modes, and that will tell the runtime that you want to see the real world through your display. So this is a preparation for augmented reality that you can use today, either with a transparent display or with a VR headset that has cameras that can show you the real world. So and how do you actually use the position data from your HMD? There is a call XR locate views, and it will tell you how to build a projection matrix and a view matrix to render exactly the perspective that you should render, depending on where you are looking and where you are in space. A big part of the specification are actions, which is basically handling input from controllers. If you have ever used SteamVR and OpenVR, the OpenXR concept is very similar to what is currently in SteamVR. So if you have a controller with a few buttons and you want to set that up in your application, there is now fixed binding like you have with traditional controllers like a mouse. With a mouse, you have left button, right button, and there's button 1 and button 3. And for XR, we have so many different controllers. Maybe you have no controller at all and just track the fingers like that without any controller. So we have a much more flexible framework. And that is based on actions. So an action is something that an application can create, and it can specify what kind of input that action should take. Currently, we have Boolean 1D vector, a 2D vector, a pose, which is basically rotation and position in space, and we can vibrate the controller, so have some haptic feedback. These actions are connected to input paths. Here is an example. The OpenXR specification specifies how these input paths should look, and it also specifies a bunch of standard paths that are connected to interaction profiles. So most of the companies that are in Khronos and specified OpenXR have put their controller schemes into the specification. That's a bunch of text here. We have, for example, the HTC Vive controller, the Oculus Rift controller, Oculus Touch controller, and stuff like that. An interaction profile basically looks like this. You have specified a bunch of input paths that this controller has, and this is what applications can use. This is a bit hard to explain on the spot. So if you are interested in how this input binding works, you should read the full specification because it takes some time to get used to. But basically, an application suggests some paths that it wants to use and a controller that it wants to use. And OpenXR runtimes are supposed to have a binding interface where the user can add their own controllers and rebind these actions to their own inputs that their controller supports. And a last concept that I want to quickly touch is spaces in OpenXR. There are a bunch of reference spaces supported. A space is basically a coordinate system that you know with the X, Y, Z axis like this, and a space can move, but all spaces move relative to each other. So you need at least two spaces, and then basically your HMD represents one space, and your room represents one space, and your HMD moves relative to a room. So the view space, XR reference space type view, represents the HMD, and local or stage space represent the room. So your view space moves through the local or stage space. There are more spaces that you can define. For example, each of your controllers that you hold in your hand can be one space, and you can get the pose of the controller through this mechanism. The interesting thing is that these spaces are not absolute ever. All of these spaces could theoretically move, and only the relative position between two spaces is what really counts. I think I will give up to Joey again.
So one of the important things, and this is somewhat related to X.Org as well, is the compositor. There are multiple ways to render on a display, and only the last year or maybe 2 years have been really good for this kind of stack. A lot of things didn't exist, also in the Linux kernel or in the display drivers. in order to do a lot of stuff. So the classic mode of rendering is extended mode, which basically treats the HMD as a display, just extending it like here's a different screen, and you can put a window on it with the correctly rendered specifications, and it would kind of work. The problem is that you don't want to expose users to like manually setting up a window on like the right screen, and it also like more latency inducing than rendering directly. So direct mode is something that's been introduced in the last 1 or 2 years. Unfortunately, it took Linux a little bit longer than Windows, where they used some hacks in order to just like skip the entire rendering system and just display on the HMD directly. There have been some vendors doing that kind of work, which was really cool, but on Linux we had to, unfortunately, invent some new methods. KMS rendering is very important for that kind of stuff, and Keith Packard actually did quite some nice work on getting the Linux kernel ready for that kind of stuff. Reprojection is a very important step as well. So basically the moment you have less information, less frames that you want, performance is of course a really important thing for VR. If you are rendering less frames than the HMD can display, then it can cause nausea really quick, and depending on the person, you have more or less tolerance to this kind of stuff. So reprojection is one of the things that you can do, where you basically duplicate frames and use prediction methods in order to reuse already known information and display that on the device to basically compensate for lower frame rates to make people less nauseous, basically. Currently, OpenXR is mostly targeting Falcon. So whenever you do an OpenXR runtime or a compositor, Falcon is what you're targeting. On Linux, that's currently the primary method for direct rendering. If you have OpenGL applications, you can use the Falcon interrupt in order to like get your OpenGL information, share it with Falcon, and basically get access that way. This doesn't really work that well on all hardware at the moment. Currently, we're limited to, I think, AMD on Linux.
And NVIDIA.
And oh yeah, NVIDIA also works these days. Intel doesn't have some extensions needed for supporting this, unfortunately. But there is hard work being done on it, of course. And distortion correction is something that you have to do because you have lenses, and lenses aren't, of course, perfect. It warps the edges, and there's chromatic aberration. So there's a step required where you either, the old method is rendering a quad, which basically has a shader with the information from the amount of distortion on the lenses and the chromatic aberration available in the lenses, and basically compensates for that. And a more modern method is using a mesh instead, because you can have a little bit more information, and it's way more efficient doing that in a mesh instead of in a expensive quad. That's kind of legacy. So currently supported hardware by Monado is whatever we can find. The HDK was a project by Razer and OSVR, which unfortunately is not existing anymore. But our great contributor who used to work at OSVR created a nice little driver, so it's really usable. It's fully featured as far as the HMD goes. And we have been doing a lot of work on reverse engineering and getting more accessible devices to work as well. We use OpenHMD in the background for a lot of the legacy devices. This is a open source C library that's been going on for a while. That does quite some reverse engineering on devices, all in different states of functioning, but at least they work to some degree. Razer Hydra has been going around for a while. Those are like positional controllers. We're using a magnetic sensor, which we managed to get working to some degree. And this week, we merged a patch for the PlayStation VR and the PlayStation Move controllers in order to use a stereoscopic camera and some calibration in order to do positional tracking for Monado. So that's currently the first real device that has like a fully featured set, which is nice because the PSVR can be get for like €300 and are basically everywhere. A lot of users have them. So it's easy to get VR running on a Linux system for not that much money. So some other notable false tracking projects. I briefly skimmed over OpenHMD already, but there are some other projects going on as well. Libsur5 has been working on reverse engineering the Lighthouse protocol, which is what the HTC and Valve are using for positional tracking of their devices. It's basically a system where they use photodiodes and lasers in order to get timing information and extrapolate positional data from that. It's pretty complex, so it's been going on for a while. And Lighthouse Redux, which is a guy who did a lot of work into basically figuring out and reverse engineering the protocol and describing it. So we had a little bit of help to get stuff working. MapLab is something that's pretty awesome. SLAM tracking is going to be like the next big thing, or it currently is the next big thing for VR and AR, because it uses inside-out tracking. So instead of the room following the headset is mapping the room. And this uses stereoscopic cameras and a lot of CFI and a lot of very frustrating DSP math in order to get information about the room. Which is pretty cool. There's some other companies already working on some SLAM solutions as well. Not really a one-size-fits-all solution, and they're unfortunately also quite heavy in processing. So we hope that that will continue to develop over the next period of time. So even though VR, AR, XR is relatively new, there has been communities for a while. There are a lot of people who get these devices and out of frustration of not having a driver start reverse engineering them. I have been part of this since 2013, just going to FOSDEM and other types of events with a couple of people, getting some apartment and a lot of beer, and basically start tinkering at the hardware and trying to make them do stuff. Which have been really fun. We had some regular hackfests organized at different type of hackerspaces, and even had people contribute hardware or contribute systems or documentation. We had donations in from all types of places of people who just want this little bit of hardware to function on whatever operating system they're using. Even some OpenBSD developer who spent like a lot of time in 2 months getting like the entire OpenBSD stack ready for some sort of VR experience, which was pretty cool. Like there was barely a Linux driver, and now we already supported OpenBSD, which was kind of fun. So it's always cool to see that the community has been going around. This is us in FOSDEM this year in February, basically just hacking along together and talking about problems within the VR space, and we continue to keep doing this with as much projects as possible. So reverse engineering is like a big part of the current infrastructure. Hopefully, eventually, we hope this is changing. There has been some efforts into creating more open platforms for VR, but unfortunately, that's not really the case yet. So reverse engineering is the only option. Since every HMD has a couple of the same components, it became kind of a routine for us. So we just get a device, trying to first see what the firmware communication is. So it's a lot of Wireshark, and it's a lot of checking out hexadecimal values and waving it around and checking if you can find an accelerometer and a gyroscope XYZ position, which is always fun. To a degree where lots of us now read hexadecimals better than ASCII. It's not great, but it's actually kind of fun if you get into it. Camera access is also very important. Unfortunately, not everyone just exposes their cameras as a regular webcam type device. So sometimes there is some specific firmware that on the USB sends over the frames in some form of encoded format and that kind of stuff. So it's always interesting to do some work to figure out what codec it is and how to process it, and figuring out latency issues or that kind of stuff. And display modes can be difficult. When we did the PSVR, we actually needed to use a hacked edit for AMD because the RGB and YIF modes are like not default to the right one. And also, like the PSVR can do 120 hertz, and by default it just reports as a 60 hertz screen. So that's literally throwing away like a lot of the reason why I really like the PSVR. So unfortunately, we have to do like quite some tinkering, but eventually getting stuff working in some degree. And now we can do a little bit of a demo of OpenXR. Of course, we have like a very important demo in graphics that that Lubos re-implemented in VR, but you will see that in a little moment. So, of course, we ported, or Lubos ported the classic gears into VR. This is currently the Monado stack with a custom compositor, currently in extended mode. The device we have here is an old, failed LG headset. It was paired up with some phone, the LG G5, and in some ecosystem that they built with modular components. And of course, it kind of failed. But it's a nice little device, 1440 by 720p resolution. It's pretty cool. So we reverse engineered it. The screens are rotated in the device itself. So we are using a compensation within the driver to render the screens sideways. They're tilted inwards, which is pretty awkward. I don't know why they did that. But yeah, we compensate for that in order to like render correctly. And as you can see on the sides, we have like this is the just rendering a shader on a quad in order to do compensation for the edges of the lenses, and doing some slight chromatic aberration correction in order to make it look nice. And yeah, this is currently running on, I think it's Falcon. Yeah. So yeah, like, this is VR, I guess. Yeah, let's go back to the slides. So wrapping up, it's been really fun so far working on Monado. We actually managed to get this out during the public release of OpenXR. So we were like together with, I think, Microsoft, the first ones to release a public, usable OpenXR runtime on Linux, which is really cool. And we hope to keep on developing this and eventually introduce more stuff into the AR and VR space. And please get in contact if you really like VR, AR, or have questions on these kind of things. Talking about questions, are there any questions? Well, that makes our lives a lot easier. Well then.
One thing we did not mention yet is why is something like Monado important, even if you don't care about open source, which everyone, of course, does. So OpenXR, as I mentioned, is loosely based on Vulkan, and like Vulkan, it is extensible. So what I previously mentioned as what is currently supported by OpenXR is not everything you can do with OpenXR. You can write your own extension, add support for more HMDs. For example, if you have an HMD that has more than one display per eye, maybe because you want a very huge field of view, then you can do an extension that adds two views per eyes, so you can use 2 display per eye. But of course, such an extension is only useful if you have an implementation for it and can actually use it. And with the closed source runtimes, of course, you can't implement them. You maybe can try it as an API layer, but that's not a very good way. So what you want to do is go to an open source runtime like Monado, implement your extension, and then you can use it from day one, show it around, show it to Khronos, and suggest that this extension should go into a standard. And if you have a running prototype, that will, of course, help you.
So I would thank you for your time. We're going to do some demonstrations later today as well, also with the XR desktop stuff. So if you have never tried VR or you want to see VR running on Linux, just find me or this guy and we can show you around.
So I will, if everything goes well, I will be doing XR desktop demonstrations. So if you haven't seen VR, I will have a Valve Index headset with the controllers, and you can try out the VR headset and, of course, the XR desktop project.
So thank you for your time. We're hiring. We're always hiring. Every company is hiring. So just yeah. Okay. Cool. Yeah. Thank you.